Hello, welcome to the video notes for lesson 6-3. This begins on page 12 in your notes packet. This lesson is about solving systems of linear equations by graphing, and this is day 2. Remember, the previous lesson was day 1, where we learned about how to solve a system by graphing. We would be looking for the point of intersection as the solution, and then we checked to make sure that it worked. So, our learning target for this lesson. Now, I can solve real-world problems using a system of linear equations. And the solution that we're going to be finding for this one is we'll be putting this in a table, but then we'll also be graphing it. So, here is the situation, the example. I'm going to move the screen up a little bit more so I can read the whole thing and see everything. Alright, Henry and Emily are siblings, brother and sister. Henry challenges Emily to a walking race. Because Emily's walking rate is faster, Emily gives Henry a 45-meter head start. Emily knows her brother would enjoy winning the race, but she does not want to make the race so short that it is obvious her brother will win. So in other words, she wants to make it a close race. Emily's walking rate is 2.5 meters per second. Henry's walking rate is 1 meter per second. How long should the race be so that Henry will win the race, win a close race? Alright, so we have a table already made for us here. We'll just simply fill it in. The details that you need to be aware of are in the problem. So remember our bucks strategy. Here's the question that we're going to be answering. How long should the race be so Henry will win it in a close race? Some important information. So we have Emily's walking rate, which is 2.5 meters. So that's her M. M equals 2.5. Henry's walking rate is 1 meter per second. That's his M. And that is 1, or 1 over 1. So, and then the other thing that's important is Emily gives Henry a 45-meter head start. That is actually going to be the B for Henry. Alright, so we have a table. We're going to show the distance from starting line at several different times during the first 40 seconds. So, let me start filling this in. I'll use blue for Emily's distance. Alright, so at 0 seconds, Emily is at 0. Remember, she's not getting the head start. Now, she's increasing by 2.5 each time. So at 1 second, it's 2.5. At 2 seconds, it's 5. Now, we could also think of Emily's situation with the equation y equals 2.5 times x, where y is Emily's distance and the x is the time. So I'm going to multiply the time by 2.5, and that's important because you'll notice this starts out 0, 1, 2, 3, but then it skips around. So you got to multiply the number by 2.5 to find out what to put in there. So this one is 7.5. But then we have 5, and 5 times 2.5 is 12.5. 18 times 2.5 is 45. 25 times 2.5 is 62.5. And 37 times 2.5 is 92.5. And then 40 times 2.5 is 100. Alright, so I'm going to go ahead and fill in Henry's distance. Actually, maybe I should start graphing this. Now, let's go ahead and fill in the table for Henry. Now, Henry, remember his M is equal to 1. So, again, I'm going to use Y is equal to Henry's distance, and X is the time in seconds. So, Y equals, so for him, his rate is 1, so I'm going to do 1 times X, or just X. But remember, he gets a 45-meter head start, so I got to add 45 to that. So at 0 seconds, he's already at 45 meters. Now, since he's going 1 meter per second, the next one is 46, 47, 48. We skip over 4, so we go to 50, 63, 25 plus 45 is 70. 37 plus 45 is 82. And 40 plus 45 is 85. So there we have our table of values. And we have equations, one for Henry and one for Emily, that can be used to help you find these values. Now I need to plot all these points. So I'm going to nudge the screen up a little bit. You might not be able to see the top after I do this. So if you didn't get all this information written down, pause the video and do it now. Okay. So the top of your screen might be a little bit cut off, but you should still be able to see enough to, actually let me just go ahead and do this. Alright, so now we're going to plot the points on the graph. Emily's are in blue. So at 0 seconds, she's at 0. At 1 second, she's at 2.5. So halfway up is 5. So halfway between that, 2.5. At 2 seconds, she's at 5. So that's halfway up. At 3 seconds, 7.5. So in between here, put another dot there. You'll see that it's linear. It should form a straight line. At 5 seconds, because we skipped over 4. Well, how about this? If we thought about 4, that would be 10, right? 5 seconds is going to be 12.5. And then we have 18 seconds. That's 45. So go over to 18, follow it up. Now there is no 45, so you got to go in between 40 and 50 and put a dot. 25 seconds. So here, go up in the middle, 62.5. So halfway is 65, so halfway between that and the bottom. Okay. At 37 seconds, we're at 92.5. So same thing. And then at 40, we're at 100. Alright, so then use a ruler and connect these and make a nice straight line. And make sure you only have one arrow, because it can't go backwards. Alright, now it's time to plot Henry's. Oh, and we should label this too, by the way. So this is Emily's. And I'm actually going to also label it with the equation, because that's how we do this for linear functions. We label with the equation. Alright, so at 0, he starts at 45, so you're going to be way up here to start. At 1 second, he's at 46, so maybe a little bit above that. At 2 seconds, he's at 47, so a little above that. At 3 seconds, 48. At 5 seconds, he's at 50. So that's going to be touching the line. Do the best you can making a straight line. It might not be perfect because we're kind of guessing the in-between numbers here. At 18 seconds, he's at 63. So go up from 18. All right, here's 60. 65 is in the middle, so it's going to be just a touch below that. A little less than halfway. At 25 seconds, 70. That'll be nice. So go in between 24 and 26. Go up to 70 and put a dot. Notice I'm using a different color, so if you have colored pencils or crayon or something, or markers or highlighters, that might make it easy. 37 seconds, we're at 82. So 37, go up to 82, which will be a little bit above 80. And then at 40 seconds, he's at 85. So right in between. Alright, again, we're going to use straight line tool, use a ruler, start here, go to here, go to the end, make it as straight as possible, and looks like about there. Alright, so the solution is going to be right here. It's actually going to be at, and now mine's not perfect, but this is going to be at 30 seconds, which is also 75 meters. So the solution meaning where they are tied. So remember, this is Henry, and his equation is y equals x plus 45. So at the bottom, let's just make this note. So they are the same distance which is 75 meters, at 30 seconds. Now, remember the question we were originally asked. So we're going to go back up to it. We put a box around it. The question we were originally asked: how long should the race be so that Henry will win a close race? Remember, we want Henry to win this, okay? So, if we were to say 30 seconds, that would not be true because at 30 seconds they are tied. If we were to say more than 30 seconds, well, if you notice your graph, which I have, I can go back to it, but if you notice your graph, if we go more than 30 seconds, then all of a sudden Emily is ahead. So what we need is just before 30 seconds. So, how long should the race be so that Henry will win a close race? The race should be, the race should be, having a hard time today, about 29 seconds. And what that will do is Henry will be just ahead of Emily, and he will win a close race. Alright, that's it for this video. There are some examples after this, and remember, there is something else we can do. We can test these answers with our check. So if I were to go to the bottom of my page here, and remember we had our two equations, so y equals 2.5x, I can substitute in my point. Remember I had 30, comma, 75. 75 would replace y, and 30 would replace x. The 30 and 75 is where they tie. And if you multiply 30 by 2.5, you get 75, and 75 equals 75. So it checks for this one. If you were to plug it into the other one, it would also check. So we can do checks on all of our solutions just to make sure that it works. Alright? If you have any trouble with this, go back and rewatch the video or come and see me for help. Good luck, and we'll see you in math.